Hello, I'm Mr. Mullen, and this is the Math Toolbox, where I teach you how to become a middle school math master. Listen, if you're watching these videos and they're helpful to you, you might want to do yourself a favor and subscribe to the channel, click the bell for notifications, and if you like the videos, like them and share with your friends. But today, we are learning about exponents and order of operations, which if you're in 7th grade, these things are not brand new to you. You should have already learned how to do some of these already, but we're going to go ahead and just cover them as we move forward. We're about to start getting into solving equations and the like, and so we need to make sure that we understand exponents. All right. This first question is, what's the difference between these two expressions? You have one expression that has a 2 next to a parentheses with a 4 on the inside, and the other expression over here, you have a 2 with what looks like a little baby 4 up to its top right. And the answer is one of them is repetitive addition, and the other one is repetitive multiplication. All right, this 2 next to the parentheses with a 4 on the inside of it, that's multiplication. And when you learned how to multiply, I would bet with about 95% accuracy that your teacher told you that multiplication is really just repetitive addition. If you have a number that you're adding over and over and over and over again, then you can write it in a little bit shorter notation using the operation of multiplication. So if you've got 2 and you're adding another 2 and another 2 and another 2, that's 4 2s right there. You could represent that as just 2 times 4. All right, and so you started learning how to multiply in about 3rd grade. And your teacher probably told you that it was just repetitive addition. And the reason why is in math, we like to be able to write our expressions in as condensed way as possible. The most condensed way as possible. So instead of writing 2 plus 2 plus 2 plus 2 over and over again, we can write it much simpler as just 2 times 4. Well, there's something really similar to that with multiplication or repetitive multiplication. If you're multiplying a number repetitively, all right, over and over and over again, then we can take this and we can kind of condense the notation to write it in exponent form, which is this 2 to the power of 4 right here. That 2 to the power of 4, all it's saying is we're going to take our base of 2 and we're going to represent that in a multiplication problem 4 times. All right, we've got 2 times 2 times another 2 times another 2. All right, so this is not, exponents is not a cute way to write multiplication. I have a lot of students, a lot of individuals that make a common mistake of seeing this 2 to the power of 4. Whenever they see this 2 to the power of 4, they just kind of see 2 times 4, which would be 8. All right, that's what we see just by looking at this, and we think, well, maybe that's just a cute way to write a multiplication problem. But this is not a cute way to write a multiplication problem. All right, it's a condensed way to write repetitive multiplication. So 2 to the power of 4 is our base of 2. All right, written in a multiplication problem 4 times. All right, so if we're going to expand this on out and write it in an expanded form, we would write that base 2 4 different times. So 1, 2, 3, 4 2s, and we put a multiplication sign in between all of those. And then we can just go about our business to actually multiply. Now, the commutative property of multiplication says we can multiply in any order and it's still going to give us the same answer. So we could do this 2 times 2, that would be 4. We could do that 2 times 2, that would be 4. And then ultimately we could multiply the 4 times 4, which would be 16. Or we could just go left to right. 2 times 2 is 4, times 2 again is 8, times 2 again is 16. Either way, you're going to get your answer of 16. So this 2 with a little baby 4 up to the top right it's called an exponent. That's saying 2 to the power of 4. It's saying we're going to repeat this multiplication of 2 4 times. All right. So exponents are really just repetitive multiplication. All right. They fall whenever we're doing order of operations, because that's ultimately the objective today, is we want to be able to simplify expressions that have that contain exponents. Whenever we do exponents in order of operations, it's in this second step, all right? So order of operations, a universal language for that is Pemdas, all right? We start out by doing our parentheses. Any of the math inside parentheses, we simplify that first. Then we're going to go on to exponents and then multiplication or division from left to right. And we're going to see a problem in here in just a little bit. That some students get tripped up on. But yeah, remember in that third step, it's multiplication or division from left to right. And then the last step is addition or subtraction from left to right, all right? Well, this exponent's right here. That's the nature of today's lesson. That's kind of what we're addressing is, you know, how to be able to solve exponents, all right, or simplify exponents, and then where do we do that in the order of operations? We do that in the second step, all right? There's a fancy definition for you if you want to pause your screen and read over that. But ultimately, you can just suffice that definition to say that exponents are a repetitive multiplication. All right. Now then, you've got some different forms. Whenever we're talking about exponents, you may have a problem that gives you an exponent, like 3 to the power of 4, and it asks you to write it in expanded form. Well, this is what it's talking about right here. It's talking about taking your exponent and just writing it out, all right? Writing it in a long form, if you will. All right, so we're going to take that 3 as our base, and we're going to write it 4 times. There's a 3 and another 3 and another 3 and another 3, right? And then you're going to include the multiplication operation in between those numbers. So it's really 3 times 3 times 3 times 3. And then you can just multiply left to right, or again, you can multiply them in any order that you want to. If it's all multiplication, you can multiply them in any order that you want to. So 3 times 3, that's 9. 9 times another 3 is 27, times 3 again is 81. Or you could do the 3 times 3 here, that's 9. And this 3 times 3 is 9. And then 9 times 9 is 81, either way. All right, so I want you to take this next one, and I want you to pause the video, and I want you to write on your own sheet of paper, take that exponent right there, 4 to the power of 3, and I want you to write it in expanded form, and then I want you to write it in standard form, which is just a fancy way to say, what's the answer, all right? Standard form is, what is the answer, all right? So, again, pause the video, try this one at home. All right, if you tried this one at home, the expanded form is going to be the base of 4 written in a multiplication problem 3 times. So you've got 4 times 4 times 4. And 4 times 4, that's 16, times another 4 is 64. So the exponent form would be 4 to the power of 3. The expanded form would be the 4 written out in a multiplication problem repetitively 3 times. All right, and then the standard form is just the answer. What's the answer? And that's 64. All right, try this next one. On this next one, I want you to take that expanded form, and I want you to write it in exponent form, and then I also want you to write it in standard form. So go ahead and pause the video and try that. All right, the expanded form is 2 times 2 times 2 times 2 times 2. All right, I see a 2 as my base. That's the number that's being multiplied repetitively, and I'm going to count. How many times is it being multiplied? There's 1, 2, 3, 4, 5 times. So my exponent is going to be 2 as my base to the power of 5, all right? My exponent is going to be 5, all right? And then my standard form is just going to be completing the math, all right? What is 2 times 2 times 2 times 2 times 2, all right? 2 times 2 is 4, then times 2 again, that would be 8, times 2 again is 16, times 2 again is 32. So 2 to the power of 5 is 32. All right, not too difficult, not too difficult at all. Now let's go ahead and go forward another step because we want to be able to simplify expressions that contain exponents. And let's take this problem right here, this expression, 4 to the power of 6 divided by 8 to the power of 2 minus 3 times 5 plus 6 plus 4, all right? There's a lot of operations going on, a lot of different things going on. So you always want to remember in this case right here that you're going to use order of operations to be able to walk through this problem, to do this problem. You want to make sure that you have a method to your madness. You're not just going left to right, you're going through the order of operations. So you start with the parentheses, then you go to the exponents, then multiplication or division from left to right, then addition or subtraction from left to right. So go ahead and pause the video and try it yourself. All right, if you have tried it, all right, we've got 4 to the power of 6 divided by 8 to the power of 2 minus 3 times 5 plus 6 plus 4. All right, here we go. I'm going to go ahead and I'm going to write over here my order of operations. And if you're very familiar with me, you've watched my videos before, you know that I like to do keep change opposite at the beginning, and then I do reverse keep change opposite at the end. Now there's one little rule that you need to remember if you're going to do keep change opposite at the very beginning, and it has to do with let's forget about this problem for just a second, and let's just do this one right here. 5 minus 3 to the power of 2. Right? It has to do with exponents. All right. If I were just taking this problem right here, 5 minus 3 to the power of 2. And I were going to simplify this expression using an order of operations. If you know me, you know I like to do keep change opposite at the very beginning, which means I'm going to take all my subtractions and I'm going to turn them to an addition problem by applying keep change opposite. But there's a little issue that you need to think about, that you need to remember when it comes to exponents, all right? That you need to, whenever you do keep change opposite, just like that, when the subtraction is in front of an exponent, you need to take this exponent and you need to wrap it in parentheses before you do the keep change opposite. That way you put the negative on the outside of the parentheses. That way you'd do the exponent first and then you'd turn it to its opposite. And the way that I like to tell my students this, kind of a catchy way to remember this, is we kind of look at these exponents as cute little baby numbers, all right? And this subtraction right here is something that's negative, all right? Anything that's negative involving babies, we like to protect the babies from anything that's negative. Like in life, you know, if you have a baby, you're going to protect the baby from things that are negative, things that could harm it. And so I try to use that kind of lingo to help my students remember that whenever they do keep change opposite in front of an exponent, we want to protect the baby. All right, so we're going to put parentheses around the exponent because we're trying to protect the baby. And then we can do keep change opposite just like that. And the reason why is we want 3 to the power of 2, not negative 3 to the power of 2. All right, so we change it to an addition problem, which means the next number has to be its opposite. Well, the next number is an exponent. It is a number. We just have to simplify that number before we turn it to its opposite. Again, if you got a subtraction in front of an exponent, protect the baby by wrapping the exponent in parentheses and putting that negative on the outside. Then you could go forward and simplify it on how. It would be 5 plus negative 9, not 5 plus 9. All right. But we don't have that situation in this problem right here. We have 4 to the power of 6 divided by 8 to the power of 2 minus 3 times 5 plus 6 plus 4. So we've got our parentheses first. I'm going to go to my parentheses. That's going to be an 11 right there. I'm going to scratch it down, and then I'm going to bring down everything that I haven't touched. I haven't touched that plus 4 or that 3 right there. I haven't done my keep change opposite yet. I need to do that, all right? But I'm bringing everything else down that I haven't touched. I'm going to go ahead and do this keep change opposite right now so that I don't forget about that. I should have done that right there. No harm, no foul. It really didn't mess us up. Okay, we did all our parentheses. Now we're going to go down to the exponents. And I see 2 exponents. There's 2 of them right there. One of them, I know that one off the top of my head. 8 to the power of 2 is just 8 times 8, which is 64. But the other one is this 4 to the power of 6. Now again, our brains see 4 times 6, which would be 24. But this is not a cute way to write multiplication. This is a condensed way to write repetitive multiplication. So this 4 to the power of 6 is really 4 times 4 times 4 times 4 times 4 times 4. That's a lot of 4s being multiplied. Repetitive multiplication. Now you can see really clearly why we write exponents, because if we wrote this out in our problem, our expression would get really long really fast, all right? And so we want to make sure that we can write it a little bit more condensed right here. So we can write it as 4 to the power of 6. But that's ultimately what this is, all right? Now, if you're in 7th grade, in our state, we can use calculators in 7th grade. Some states can't. But you've got kind of like two different kinds of calculators that I want to show you how to do this on. All right. Ultimately, if all else fails and your calculator is just a basic calculator like this one, all right, you can do the repetitive multiplication just by pressing the number in the correct number of times. So you could do 4 times, there's another 4, 3 4s, 4 4s, 5 4s, 6 4s, and then pressing the multiplication sign in between every time. So I've got 4 times 4 times 4 times 4, so on and so forth. Okay. Ultimately, I'm going to get 4,096. All right. A basic calculator, when all else fails, you just press the multiplication into the calculator. So you write it in expanded form, and then you count how many times you're pressing the number. You're just going to press that number however many times the exponent tells you to, and you're going to write press a multiplication sign in between. All right. But then you have some calculators like this TI-30 right here that have a special function for multiplication. Let me clear it out, or for exponents, sorry. All right, and it has to do with this little arrow key right there. So the way that you would do 4 to the power of 6 on this calculator, a TI-30, is you'd write the base first, that's 4, all right? Our base is 4, and then our exponent's 6. So in between, you'd write the base first, type the base first, and then you're going to hit the little arrow key right there, right before you hit the exponent. So the base first, that's 4, little arrow key, and then I'm going to write my 6, or type my 6, that's my exponent. So you have in the calculator, it says 4 to the power of 6. Press enter, and you're going to get your same answer that we got by doing it repetitively. All right? So again, basic calculator, all else fails, just go ahead and multiply. Just remember how many times you're pressing the number in. A little bit better calculator, TI-30, which is what I like to use in my classroom for my students. You can just press the base, then you press the exponent key, then press the number that's the exponent, hit enter, you got your answer. All right, so we've got 4,096 right here. All right, we did that math. We're going to bring down everything that we haven't touched. All right. Really important step in the process is bringing everything else down. So doing the math that you can do, don't just try to depend upon your head. Because 7th grade, yeah, you can do a lot of mental math. But as you get older, as you get into higher levels of math, it's going to be really important that you understand how to do a process, how to go through a process. So I'm really big about process. Do the math that you can do, then cross it out up here. I did this 8 to the power of 2, that's why I crossed it out and I wrote 64. I did this 4 to the power of 6, I crossed it out and I wrote it down here, it's 4,096. And then I brought down everything that I haven't touched. I haven't messed with this division yet. That plus sign, that -3 or times 11 or plus 4. I haven't messed with any of that other stuff, so I'm just going to bring it down and move on down to the next step. Now then, all my exponents are done. Okay, so I'm going to go ahead and move on down to multiplication or division from left to right. Now this step right here, a common mistake is students want to do all the multiplication first. But here's the reality, multiplication and division, they're in the same step. So you want to do it whatever you see first from left to right. We see division first right here, so we're going to have to do that division first. I've got 4,096 divided by 64. I want to do that division first, all right, which is 64. All right, so 4,096 divided by 64 is 64. All right, now I'm going to bring down everything I haven't touched. I haven't touched that plus or that -3 times 11 yet, or this plus right here. All right, I did the division. Now I want to go and do this multiplication. -3 times 11, that's -33. Cross it out, bring down everything you haven't touched, just like that. All right? And we did all of our multiplication and division. Final step, we've got addition or subtraction, which, if I do keep change opposite at the very beginning, I eliminate all my subtractions. So really, when I get down to this 4th step of Pemdas, I just have addition all the way across. And I could take my numbers, positive and negative, and I could put them on a tug line, all right? Again, if you know me, you know I like math tools. I like to use a tug line, all right, where I like to organize my positive and negative numbers, put all my negatives on team negative, all my positive on team positive, add them up, team totals. I have 68 positives, 33 negatives is their award. Yes, 68 minus 33 is 35. That's the difference. All right, and who won the war? The positive had a bigger team, so the positive won the war, and that is our final answer. All right. At the very end, this reverse keep change opposite, that has to do when you have variables present. If you have any plus negatives or minus negatives, we like to clean our expressions up to turn plus negatives back to subtraction or minus negatives back to addition. All right, so that's not really a necessary step, obviously, when you don't have variables, because you don't have any plus or minus anything else, any other terms that you're adding or subtracting off of this. So we simplified our expression, and we got the answer of 35. All right. So now then, I want you to try this next one. All right. Try that one. Go through the order of operations. Pause this video, and then come back and get the answer. All right, so we've got 7 to the power of 2 plus 5 to the power of 2 divided by 2 times 3. All right. All right, this one's got a lot of things, a lot of places inside this that would trip students up. But the first thing we want to do is write down our order of operations. I like to write it like this, where the P is in one step, the E is in one step, the MD are in the same step, and the AS are in the same step. This reminds us there's just 4 steps of Pemdas, not 6. Okay? We're going to go to our parentheses first, and inside of our parentheses, we have 2 exponents that we need to simplify and we need to add together. So I'm going to start by doing the exponents. I've got 7 to the power of 2, that's 49. I'm going to cross that out because I did that part. I've got this 5 to the power of 2, that's 25. I'm going to cross that out because that's the math that I did. Now I'm going to bring down everything I haven't touched. All right? I see this plus sign right here, this division sign, this 2, and this 3. But I just made a mistake, all right? And I made it on purpose. But I wanted you to see how easy this can happen, all right? Look at my expression right here and see if you can guess, all right, where my mistake was. What did I forget to write? All right? I forgot to write the parentheses right here, putting it down here. It's really important. If I haven't I haven't simplified this parentheses, that I'm going to bring that down and wrap it, all right? I'm going to go ahead and pull all that down. Because if I don't, it looks like I need to do this division before I do this addition. But this parentheses right here was telling us we want to do this first, right? So whenever you're bringing things down, make sure you're very careful to bring down the parts that you haven't touched yet. I haven't simplified this parentheses yet, so I still need to include that. Now then, I can go ahead and finish on adding these numbers inside this parentheses because we're still in this first step of Pemdas. 49 plus 25 is 74, all right? And I did that math, and I'm going to bring it down everything else I haven't touched, just like this, okay? And I did all my parentheses. Now then, I don't have any exponents left because my exponents were inside my parentheses when I went to simplify them, so I already did that. Now I've got multiplication or division from left to right. And in this expression right here, there's another common mistake that students would do. Right? Students, a lot, want to do all the multiplication before they do anything else. All right? But this step right here, this third step of PEMDAS, tells us we need to do multiplication or division, whichever comes first from left to right. So I need to do this division before I do this multiplication. Right? There is no commutative property of division and multiplication. The commutative property only applies to multiplication. So I cannot move these numbers around and do them in any order that I want to. At this point right here, because I have 2 different operations present, I have to go left to right. So I have the 74 divided by 2, which is 37. I have to do that first before I multiply by 3. Right? Finally, I can do this 37 times 3. That's going to be 111. Right? Now I had students earlier this morning when we did this, they wanted to do this multiplication first. They got 6. They divided 74 divided by 6, which is, they got 12.3 repeating. If you got this answer right there, all right, which is a wrong answer, All right, if you got that, the reason why you got that is you did this multiplication before that division, and you can't do that. You have to do the multiplication or division in the step, whatever comes first from left to right. So in this case, the division came first, so I had to do that one first. All right, last problem. Try this one right here. All right, last problem. We've got 19 minus 3 divided by 3 to the power of 2 minus 1 minus 2. All right. Again, I like to do keep change opposite at the very beginning. All right, so I'm going to do keep change opposite here, keep change opposite here, and keep change opposite there. And none of my numbers, all right, after the subtraction had exponents, so I didn't have to worry about protecting the baby. But you do want to think about that. If you're going to use keep change opposite at the very beginning, then you're going to have to remember that one little thing, that in front of an exponent, you have to protect the baby. That's the bell, so I need to finish this up pretty fast. 19 plus negative 3, that's 16. That's my parentheses. I'm going to bring down this division because I haven't touched it yet. Inside this parentheses, I have 3 to the power of 2, that's 9. Plus negative 1, that's going to be an 8. All right, I did that math. I'm going to bring down everything I haven't touched. Did all my keep change opposite, all my parentheses. I don't have any exponents left because that was inside my parentheses. I'm down to multiplication or division from left to right. 16 divided by 8, that's 2. I'm going to cross that out, bring down what I haven't touched. And then down to the addition or subtraction from left to right, I have 2 plus negative 2, that's 0. So my final answer is 0. All right. I hope you enjoyed the video. If you have any questions about this, you can type it in the comments down below. Hope you have a great day. Again, encourage you to subscribe to the channel. We're going to get through all the way through 7th grade math this entire year. If you ever need help, come. I'd be glad to help you. All right. Have a good day.